Our daily life is intimately connected with electromagnets because it is almost impossible for us to spend a day without electronic devices. And all electronic devices are electromagnets. In today's video, we will learn what an electromagnet is and how it works. Let's get started. 1820. Hans Christian Oersted. He was the first to discover that electric current creates a magnetic field. That is, there is a relationship between electricity and magnetism. Just 4 years later, in 1824, William Sturgeon passed current through a piece of iron by wrapping an insulator around it, which works exactly like a permanent magnet. So it can be said that the inventor of the electromagnet is William Sturgeon. However, its theoretical basis is given by Oersted. Now let's first look at the properties of permanent magnets. Then we will learn about electromagnets. A permanent magnet has two sides, a north pole and a south pole. Like poles repel each other, and opposite poles attract each other. Once a permanent magnet is made, its direction cannot be changed. That is, the direction cannot be changed from the North Pole to the South Pole. That is, after a permanent magnet is made, the directions of its poles are completely fixed. What you see on the screen now is the field lines of a permanent magnet. The force lines on the south end point outwards, and the force lines on the north end point inwards. This is the characteristic of a permanent magnet. Let's take a look at what an electromagnet is and how it works. We already know that electricity creates a magnetic field around the conductor it flows through, but the amount of this magnetic field is very small. If a coil is made by winding an insulated wire, the magnitude of this magnetic field increases many times, and it acts exactly like a permanent magnet. We said earlier that the direction of a permanent magnet cannot be changed. That is, the North Pole cannot be changed to a South Pole. But the direction or poles of an electromagnet can be easily changed. Let's see how. You have made a coil by twisting a single wire or wire and passed electricity through that wire. Now the direction from which the electricity flows will become the South Pole, and the opposite direction will become the North Pole, which will work exactly like a 100% permanent magnet. To understand the matter better, look at the figure, where a coil is made by winding an iron rod with an insulator. And here is a battery. The coil is directly connected to the battery through an electric wire. Now the current will start flowing through the coil, and that will be from A to B. That is, in this diagram, electricity is flowing from A to B. Then, end A of the coil will become the South Pole, and end B will become the North Pole. Again, I turn the battery. Now the direction of the flow of electricity in the diagram will also change. That is, now the electricity will flow from B to A. As a result, the B end of the coil will change to the South Pole and the A end to the North Pole. That is, the definition of an electromagnet is a magnet that is created by an electric current and whose magnetism is lost when the electricity is turned off is called an electromagnet. Uses of electromagnets in real life. Electromagnets are intimately involved in our daily lives. Let's see how. From the power plant where the electricity is generated, it comes to our city or house pole at high voltage. From there, the voltage is reduced to 220 volts through a transformer and supplied to the house. Transformers work on the principle of electromagnetic induction. A magnetic field is created in its core due to the flow of electricity. But it is a temporary magnet. If there is no electricity, the transformer's core is not free. So, a transformer is an electromagnet device. Again, a charger is required to charge a mobile phone. There is such a device in the charger. It is called an adapter, which changes the voltage and gives an output of 220 to 12 or 5 volts. This also works on the electromagnetic principle. That is, it is also an electromagnet device. The most common and important example of an electromagnet is the electric motor. Electromagnets are also used inside the motor to create a rotating magnetic field. That is, an electric motor produces rotational motion with the help of an electromagnet. Therefore, an electric motor is also called an electromagnet device. Dear viewers, if you want to see how an electric motor, i.e., a three-phase induction motor works, you can watch our video. You will find the video link in the description or on the screen at the end of this video. If you like the video, please subscribe to the channel. See you in the next video. Allah Hafez.